This module deals with the basic principles of drawing the shoe last from the side. This is an example of the basic shoe last from the side inserted into a unit sole. This is a classical last which we are going to deal with in this module. The ultimate goal is to get you to do quick pencil sketches like this one, which was done in about 30 seconds. Before attempting this module, you must first do the module on the shoe last. To do this module, you will need the following items: pencil, eraser and A4 white paper. Do not use any rulers in this exercise. The intention is to be able to do everything freehand. You need to spot the lengths and you need to spot halves and quarters using only your eye. First, we have to determine the size of your sketch. To do that, we draw a surface line the length of your sketch. That is called the last length. This section will be the length of your actual sketch, with your toe end on the one side and your heel end on the other side. Once you have done that, you can continue. Next is to determine the joint area of the sketch. Halfway between your toe and your heel area, make a mark. This is called the joint. It is the area where your foot will be bending, the widest area of the last. It's a very important point, remember it. Next, we're going to understand how raising the heel affects the last. The first thing we have to understand is that when the heel rises, it rises around an arc which circles around the joint. This, in other words, means that it doesn't matter how high the heel is, the distance between the joint and the heel is always the same, irrelevant of the height of the last. Next, we're going to show you actually how these heel heights affect the heel itself. On a 10mm it's low, right at the back. On a 30mm it's moves slightly forward. On a 80mm it's much more forward, and on a 110mm it's almost halfway between the back where it was on a low heel and the joint. And the same happens when it goes down again, it moves further away from the joint area. Now that we have our 10mm heel height in place, we are going to determine the seat area of our last. The seat area is the area where your heel will rest on. To do this, we merely draw a line from our heel height to the toe of our last, and the area around the heel height on that line is our seat area. This applies to all heel heights. As the heel goes up, you will notice the seat area pitches more. As it goes down, the seat area pitches less. Next, we're going to draw the counter area of the last. The counter area is the area on the back of the last where your heel is. From our seat area, we draw a 90-degree line upwards at the heel height. Gives us the angle between our seat area and our back height marker. To determine our back height marker, we need a quarter of our total last length. This is 1/4 of the length of your sketch. We then apply this length, quarter of the last length, upwards against the back line from our heel height. Then just slightly below that marker is our back height marker. This back height marker is the highest point that our shoe can go before digging into our Achilles heel. Then, to determine the top of the last, we take 1/3 of the distance between our heel height marker and our back height marker and apply it above the back height marker. From this point, we go out 90 degrees from our back line again, and we will end up with two parallel lines between the seat area and the top of the last. This stays the same no matter what the heel height is. We can look at what happens in the process. When the heel goes up, the seat pitches more, but the square stays the same. The seat area and the top of the last remain parallel, and the back remains square. Next, we're going to determine the shank curve. This is a simple process of blending the seat area to join the joint. As the heel goes up here, this curve becomes more dramatic in order for the seat to get to the joint area. The higher it goes, the more dramatic this curve is. And the lower it is, the flatter it is. Great, now that we have the back of our last done, we are going to do the front bottom of the last. This is done with one smooth line extending from our shank curve to a point slightly raised above the toe point, which is called our toe spring. You will see as the heel goes up, the curve at the joint actually moves forward, and the contact point where it touches the surface also moves forward. This is a rolling action by the foot when it actually raises up. Now that we have the bottom of our last finished, we're going to draw the back curve. The back curve is drawn on our back line through the point we call our back height. We take an angled line slightly in at the top and out at the bottom, and we blend this line at the bottom into our heel height point. Note that this line goes through the back height at a slight angle and is almost straight at the top and only curved right at the bottom. The next challenge is to find the vamp point. The vamp point is an extremely important point, and you need to concentrate here. The first thing we have to do again is determine a quarter of our sketch length or last length. The vamp point lies a quarter of the last length away from the joint. In other words, it will lie on this curve around the joint. It doesn't matter what heel height it is. The question is, however, where on this arc does the vamp point actually lie? The answer to this is the vamp point and the joint always lie the same distance from the back height, irrespective of heel height. So to find the vamp point, we first measure the distance from the back height to the joint and apply the same distance from the back height towards this curve, and that is the point where our vamp point is. So to sum this up, our vamp point lies the same distance from the back height as our joint is from the back height, and our vamp point is a quarter of our sketch length from the joint. This gives us an equal-sided triangle from our back height, vamp point and joint, where the short edge is a quarter of the sketch length, and that is also our girth line. To clarify this even further, if we have to take a point halfway between our vamp point and our joint, this will be our top line point, and a line joined from our back height to this point will be our top line. This top line will thus run 90 degrees into our girth line, which is the line between our vamp point and our joint. Now that we have our vamp point, let's have a look at what happens when the heel goes up. You will notice that the vamp point moves further forward, but everything else stays the same. The top line stays 90 degrees to the girth line. Now that we have the van point, we're going to draw the front of the last. We start off by joining the van point to the toe of the last and finding a midpoint on this line. At the midpoint, we draw a diagonal line across that line with the front side of the line the height of the toe we're going to do. Remember that this is a classical toe, so it cannot be too high and nor can it be too sharp. It has to have a very conservative height. The next thing we have to do is determine the pitch of our cone. To do this, we draw a vertically up line from the midpoint of our shank curve, half our sketch length, and join the top of this line to our van point. This line will give us an indication as to what the pitch of our cone should be. The next step is to draw in the front curve. We start from the toe point, moving 90 degrees up and curving backwards onto the perpendicular line to create our toe. We then move upwards through our van point and then bulge outwards to create our cone curve to join the top point. This must be one single line with no sudden changes in direction. It is smooth with no bumps. We then extend the top of our last forward to join the cone line at 90 degrees. This will give us our final product, which is the side sketch of a shoe last.